In this video, we will compute the derivatives of sine of x and cosine of x. First, let's remember that in one of the previous videos, we have seen that this limit here of sine of h divided by h, when h goes to 0, is equal to 1. And we have computed this limit by looking at the unit circle and by comparing the geometric interpretations of the angle and its sine. And very similarly, if you look at the same picture, you can also check that the second limit here of cosine of h minus 1 divided by h is equal to 0. Now, the meaning of these two limits and also the reason why we are looking at them right now is very simple. So for example, if you remember that sine of 0 is equal to 0, then we can rewrite this as sine of h minus sine of 0 divided by h. And when we let h go to 0, of course, we recognize that this is just the definition of the derivative of sine at 0. And in the second case, if we use that cosine of 0 is equal to 1, then we can rewrite this as cosine of h minus cosine of 0 divided by h. And again, when we let h go to 0, this is just the definition of the derivative of cosine at 0. So what these two limits are telling us is that the slope of sine at 0 is equal to 1, and the slope of cosine at 0 is equal to 0. Now next, we will use these derivatives of sine and cosine at 0 to compute the derivatives of sine of x and cosine of x for any x. So for example, let's try to compute the derivative of sine of x. Now by definition of the derivative, we have to take sine of x plus h, subtract sine of x, then divide by h and see what happens when h goes to 0. And the main thing we have to do here is use the trigonometric formula for the sine of the sum of two angles, which of course is sine times cosine plus cosine times sine. And then, if you compare the first and the last term, both of them have sine of x as a factor. So if you group those two terms and then factor out sine of x, you can rewrite them as sine of x multiplied by cosine of h minus 1 divided by h. And then the second term here, we'll just leave it as it is and write it as cosine of x multiplied by sine of h divided by h. Okay, and finally, when we let h go to 0, we can see that the two factors here that depend on h are exactly the limits that we just discussed. So the first one goes to 0 and the last one goes to 1. So that means that the sum of these two terms will be 0 plus cosine of x, which is cosine of x. And so this shows that the derivative of sine of x is equal to cosine of x. And exactly the same calculation, just using at the first step the trigonometric formula for the cosine of the sum of two angles, you can check that the derivative of cosine of x is equal to minus sine of x.